Maximize cloud efficiency with Doit, the trusted partner in multi-cloud management for thousands of companies worldwide. Visit doit.com. That's DOIT.com. Doit, your cloud simplified.
Monitoring overall observability with traces, metrics, logging, performance, it is obviously one of the most important aspects of not just Kubernetes, but anything tech related, whether you're in the cloud, whether you're on-prem, it is arguably one of the most important pieces. But what if you want a way to almost have a central platform for everything observability related and also have a location where various observability tools or various monitoring tools can pull the data from? And that's exactly what we're going to be talking about today with OpenTelemetry. My name is Michael Levan.
My name is Kristina Devochko.
And today we have Dotan Horovits on from logs.io. Is that right?
Yeah, logs.io, and also a CNCF ambassador in another hat. So another aspect that relates to the show.
Awesome. But yeah, we're all CNCF ambassadors here, I think, which is cool.
Yeah, nice.
We're going to be talking about everything and anything OpenTelemetry. This is definitely a topic that could span probably days. Unfortunately, I don't think that we can spend 4 to 5 days recording a podcast, so we'll have to cut it down to about 20 to 30 minutes. But why don't you tell us a little bit at a high level, that 1 to 2 liner of what OpenTelemetry is actually going to be doing for everybody?
OpenTelemetry is a framework, observability framework for generating and collecting telemetry data across your infrastructure, application, across different signal types, logs, metrics, traces, and more in a unified, uniform, and vendor-agnostic manner, and based on open specification. So it's not just a tool, it's also the specification for how to model and how to relay this telemetry data.
Okay, very, very cool. It's essentially this central platform that we can essentially take data from, push it to where we want it to go.
In a way, take from is might be taken different ways. So I guess the first step is the instrumentation, where you extract data from your application in a uniform manner. So that's usually where people start, at least on the application type of observability, where you need to instrument your application. The pain has been for many years. You used to do that with libraries, Java, you had the log4j and logback and things, and you have and .NET and Python. So each programming language has its way of doing that, and each monitoring, logging, observability tool had its own way of collecting it. And we had the Telegraph, and we had FluentBit and FluentD, and the Elastic beats, various beats, and all of that. And so it was very much like point solutions for each programming language, each vendor, each tool, each open source. Jaeger had its own tracers and so on. And usually it's also great tight coupling with the backend, because so you use Jaeger traces to send it to Jaeger, you use the Elastic beats to send it to Elasticsearch, and so on and so forth. So it was very vertically isolated, based on signal, based on programming language, based on this, that. And this is the pain, because when we talk about observability, it's all about being able to ask questions, especially ad hoc questions that we haven't prepared for in advance. And this is, I think, the big win with OpenTelemetry.
So I guess the huge strength that really was the reason for why OpenTelemetry adoption has really taken off during the last years is that standardization that it provides when it comes to observability and offering this pluggable architecture of the OpenTelemetry project, where you're not married to a specific vendor, you can say, where you could just plug those, for example, exporters, depending on what tool you would like to use and to export your data to. And in the same manner, easily replace it without fully refactoring the code in all of your applications.
Yeah, exactly. Maybe you mentioned a few terms that I'm not sure if your listeners are familiar. So just very, very high level. OpenTelemetry is a massive project with lots of components and specifications. So I would say that broadly speaking, we can talk about 3 main pieces. One is the instrumentation piece, which is a set of SDKs, per programming language and auto instrumentation agents and libraries and so on. This is for the instrumenting your application. Then there's the OpenTelemetry collector. That's sort of a data processing pipeline to collect telemetry, process it and export it. And essentially what you mentioned, the pluggability, is thanks to the architecture that allows to plug in different receivers in different protocols to get the telemetry from different sources, and also different exporters to send it in different protocols to different backends. So these are two pieces. Maybe the third piece that is worth mentioning is the OTLP, the OpenTelemetry protocol, that defines the way to transmit this data in a uniform manner. So just for the listeners to understand what you were rightly saying, and going back to what you said, so once you're based on this architecture, first of all, you have the freedom to choose which backend you use. OpenTelemetry doesn't take any stake in the backend, so you want to send it off to Prometheus, to Jaeger, to Datadog, to Logs.io, to AWS cloud services, or even downstream like Kafka, to put it in a pipeline, eventing, and then stream it forward. It's very easy to do it with the relevant exporters. The decoupling from the backend, this is a major advantage, a major benefit that there is. And on the ingestion side, again, you can collect obviously from the SDKs of OpenTelemetry, but you can also collect from many other sources. So you are in a Kubernetes show, obviously. So you have a Kubernetes receiver that can natively ingest, and you have similar for Docker and for Apache and for Jenkins and for whatnot. So you have the flexibility to really plug and play with whichever infrastructure you have and whichever backend analytics tool you wish to use.
So interesting. You mentioned the Kubernetes receiver right now, and can we dive a bit deeper into that? Can you tell us a bit more? What is this about? Because also when it comes to OpenTelemetry in general, what maybe many of the listeners and myself also can relate to is that it's mainly about kind of integrating the observability piece in your applications. But what about where application is running, where application is hosted, for example, in Kubernetes? How does it all fits in together? Can you tell us a bit more about that?
Yeah, certainly. And maybe a word before specifically Kubernetes, it's very important what you just said, because many people think about it in case of applicative monitoring, but it's definitely not just limited to applicative observability, and also for infrastructure observability. And as I said, could be VM type of information, or a container runtime type of information, or Kubernetes type of information, or many others. You can collect and relay both infrastructure and applicative. So, and the reason I think people think immediately about application is because of that other piece of OpenTelemetry. That's the SDKs for instrumentation. And this obviously is to instrument your application. So you're writing a front end in Node.js and a back end in Java. You can instrument this and that with the respective SDKs. So this is why people think when we instrumented our application with OpenTelemetry, then OpenTelemetry is meant for collecting application monitoring and observability. No. So you can also relay through the same collector. In addition to your application one, you can also relay infrastructure. Again, it could be Kafka, it could be GitHub, I think, has a plugin and a receiver, and many, many others. So that's an important note to say. And one other note that I wanted to say, maybe beyond the tools that I mentioned, these three tools or pieces, there is the OpenTelemetry specification that is not a component in its own right, but it governs all the components. And that is very, very important. Actually, what I said at the beginning about needing a unified way of relaying that is independent is thanks to that open specification. So OpenTelemetry defines a data model and the API specification and the SDK specification for OpenTelemetry, agnostic of even the programming language. And then the SDKs, as I mentioned, then go about and implement the API and the SDK for each one API, one SDK, of course, per programming language that implements the specification. But then you know that, for example, your front-end instrumentation and the back-end instrumentation will still, if you work with the OTel SDKs, will then come out with the same resulting OTLP type telemetry, regardless of the instrument, the programming language. So this is a bit unlike, Go has its own way of doing traces, and the Java has, and so on. So this decouples that. So this is about that. And specifically to Kubernetes, because both of these obviously are under the CNCF, there is a lot of synergy between them. I think the first thing that I would say, and that is probably the first thing that will interest many of the people here, is when you come to install it, you can use an operator, an OTel operator that through which you can install the collector. And then, just like you do for the rest of your stack, you feel native. The collector is with the guarantees of the lifecycle management and the resource allocation and all of that. So that's one way. And obviously, part of the operator defines also the instrumented elements. So you get some of the infrastructure elements out of the box. Another thing that I think is very useful for Kubernetes users is metrics. And in addition to the Kubernetes one that I mentioned, there's also a Prometheus receiver. And because many of the Kubernetes ecosystem components expose out of the box an OpenMetrics native or Prometheus native endpoint, then you can ingest that or receive that with the Prometheus receiver. That's also important because then you don't need to convert anything and you don't need to do this work to collect the standard Kubernetes metrics just with OpenTelemetry collector rather than with the Prometheus node or Prometheus agent mode if you just use that for collector. So I think these are two elements that prove a lot very useful. And one question that arises often in this regard is, what about the data that is emitted? Because Prometheus has its own format and OpenTelemetry, as you said, there is its own format. So this has been an issue at the beginning, and then a lot of work that has been done between the two groups, between the Prometheus community and the OTel community, was managed to bridge the divides and mitigate the gaps so that today there is a very clear conversion between Prometheus native to OTel native.
Yeah, makes sense. So with stuff like Cube State Metrics, the metric server, that is the thing that's going to open up, the ability for OpenTelemetry to start ingesting that data. So with Kubernetes, it obviously makes things a little bit easier, but maybe you could tell us about a circumstance like that, but maybe it's not Kubernetes. Maybe it's a virtual machine in AWS or even like something bare metal. I mean, are there any scenarios with something outside of Kubernetes that you could tell us about?
So I think that, first of all, the under the Kubernetes, usually people run Docker is still very popular, but other CRIs, I think this is something that is proves to be very very popular and very useful. So you augment with the layer underneath that, and in addition to that, usually what you see is depending on the obviously on the operating system and what you use. I think you find things such as many run on the cloud, for example, then you can collect from AWS X-Ray, GCP PubSub, collect D. If you use collectors like the old school collectors, you don't need to replace them. You can use you use collect D, for example, you can pull it from collect D. If you have data components like a database, Redis, MySQL, Kafka, again, you have the receivers from these. So really, the infrastructure is today very a thick layer, depending on what kind of that. But I'm saying from the container runtime all the way through to really components such as data streaming and data processing and then data storage. All of these you can collect through that, and you can maintain your or previous collectors if you so choose. Which may be just one very important note that is also important. I mentioned different components. You don't have to use all of the components that I mentioned to align with OTel, which is something that I really like in terms of the elegance of the architecture. You can use the SDKs without the collector, like you can export from the SDKs directly to your backend. You can use the collector without the SDKs. As I mentioned, you have native protocols that are not OTLP that you can ingest. So it's really flexible to take the pieces that are relevant for you. You're not bound to use the entire suite, which makes it also the adoption. You can do it in a gradual manner, and you can keep some of the things that you had before. So you had Prometheus metrics already in use. You can ingest the Prometheus metrics. You don't need to now change all the instrumentation. Or you have the Jaeger or Zipkin traces. You can use that. Although Jaeger is now, I don't know if you heard, but realigning with OTel. So it's modular. So OTel does aim to provide a holistic solution framework for observability that covers the whole spectrum, but it is flexible in terms of the way that you adopt and consume.
Makes sense. So OpenTelemetry isn't yet another monitoring tool or another observability solution. It's really something that's simply ingesting the data and sending it out to where it needs to go, whether that's Prometheus, whether it's Jaeger, whatever the destination is. And vice versa, right? It could also be ingesting from those locations. Or no, it's just one way, right? It's just sending the data out?
So there are the two pieces. There is the piece of emitting the data, which is the instrumentation, the client libraries, SDKs, auto instrumentation agents, and so on. Maybe you can devote a bit of time about auto instrumentation in a bit. So this is the part of emitting or generating telemetry. And then there's the piece of collecting the telemetry, which is the auto collector essentially that ingests the data. So you have both capabilities to generate and or again, because we said we don't have to use both, but generate with the client libraries and collect with the auto collector, broadly speaking.
Got it. Is there one of those that's more popular than the other? Like what are people primarily using it for? Or are they using it for both?
I think the collector is very popular just because you don't have to convert your existing telemetry that your system emits, especially if you have like pieces, third parties in your system, like I mentioned, Kafka, Redis, and so on. They can't change their code, obviously. You can't instrument them, and you need to wait until the project or product will adopt OTLP. So auto collector doesn't have this constraint. You can just ingest anything that you have, legacy protocols, newer protocols, diverse protocols. So I think this is very, very easy. And usually people used to have similar things, maybe narrower in scope, like people used to use FluentD or FluentBit for logs and Telegraph maybe for metrics and things like that. So people are accustomed when you have architecture at scale to use some sort of an agent daemon collector that does that. So it plugs very nicely into, okay, let's put auto collector as the component to collect across the different signal types, across the different programming languages, infrastructure, app, and so on. So I think this is the place where many people see value. And on the other hand, I do see other people having a different journey. For example, organizations that decide to adopt tracing. This was the first signal to have matured, achieved stability in OTel. So many started their journey with OTel. So OTel was their canonical way to instrument the application to emit traces. Whereas logs usually, all of them already had logs somewhere. So I guess the journey depends on where you come from, what your needs are, and many that started from tracing actually started with the instrumentation in OTel. Others started from the collector, as I mentioned, to unify different infrastructure and app collection of metrics and logs and so on. These are, I guess, broadly the patterns I see.
And maybe to clarify this for our listeners, since you also did a really great job so far clarifying like the different components that OpenTelemetry consists of, like instrumentation, collectors, exporters. The same we could say for data, that there are three types of data that you can collect: metrics, traces, and logs. And you actually said it while I was trying to remember, was it traces or was it logs that was the one that was longer to be GA or to be supported, I think, by the different SDKs, especially like for me, who does a lot of .NET development, used to do it. I remember that the logs was the one that was, I'm wondering, I think it's still in preview. I don't think it's still GA at this point, but if you know something,
I think,
please
yeah.
correct me.
So several things. First of all, you mentioned something, maybe I should have said it up front. So OTel is not one monolithic project. So it's comprised of different working groups and different pieces, as I mentioned. And the importance here is to understand when we talk about, okay, is that stable, is this GA? Because it's not that OTel is GA or not GA, it's the different pieces. And this is why it makes it a bit trickier when you adopt, because you need to understand where each piece is in the maturity cycle. But thankfully now logs, metrics, and traces as signals and as specifications are all GA'd. So up till a few months ago, logging was still not GA, not stable. We had to say, no, if you're for logging this, now at least the three pillars of observability, as people call them, are all GA in terms of the specification. And they already have, and I think .NET actually is there, by the way. I think the .NET is stable as part of the announcement of...
It was a while ago I checked that, so it may be...
So I think
now.
Java, .NET, C++, and PHP are all stable also for logs.
Nice.
And actually, don't mind me plugging a shameless plug for my own podcast, Open Observability Talks. The recent episode was about .NET 8 that is upcoming hopefully before the summertime in the Northern Hemisphere. And it should be with a lot of observability capabilities. There's even a whole framework called Aspire that is focused on cloud native development and observability. And part of that, which was very interesting to see, is really the adoption of OpenTelemetry as part of the language. So you really see OTel native support also by the services themselves emitting out of the box by default OTel like health check metrics and things like that. So if you are interested and if you're a .NET person, I invite you to check out the latest episode of Open Observability Talks with David Fowler. If you're a .NET person, you probably know David Fowler is a big name in the .NET community. But going back to your question, so really these are the pieces, and this is why we're talking about maturity. And one other very important thing is that it's not just logs, metrics, and traces. And actually, KubeCon last year, 2023, we announced OpenTelemetry decided to venture into the next signal. Now that these are GA'd, the next signal is continuous profiles. So it's no longer just logs, metrics, and traces. And we actually had a very meaningful milestone when the OTEP, the OpenTelemetry extension proposal, was accepted. So now it's formally part of OTel in an experimental mode. So the maturity lifecycle in the CNCF is like draft, experimental, then stable, which is GA, if you like, in plain terms, and then deprecated, obviously, for all the things. But so now it's experimental after the OTEP has been merged. Really big news. This is actually the topic of this month's podcast that is coming soon, which is about this major milestone. I have a couple of SIG members from the special interest group for profiles. A lot of activity has been done there. The data model has been already there, so you can actually see a unified data model for profiles as part of OpenTelemetry. It's sort of a pprof extended for those who are a bit familiar with profiles. So you probably know the pprof standard. So a lot has been going on both in terms of expanding the signals beyond the three pillars and also in other terms like going beyond the back end and into front end related like real user monitoring, client side telemetry, about things like auto instrumentation using eBPF and other things. A lot is going to be going on. This is the second most active project in the CNCF after Kubernetes itself. So.
Let's take a quick sponsor break. Maximize cloud efficiency with Doit, the trusted partner in multi-cloud management for thousands of companies worldwide. Doit's innovative tools, expert insights, and smart technology make optimization simple. Elevate your cloud strategy and simplify your cloud spend. Visit doit.com. That's DOIT.com. Doit, your cloud simplified. And now back to the show.
This is, to me, sounds like quite a challenging journey to be on as an open source project, developing a standard from the ground up, basically, and with so many tools out there in the observability space. And I mean, so many probably requests that are coming from different use cases, from different adopters, and trying to kind of decide what to introduce support for, at the same time keep the standard good and stable and mature. I'm just curious, like, did you, as maintainers and contributors of the project, have there been any challenges that you know of? What has been difficult? What has been challenging when working with kind of OpenTelemetry projects and this broader and increased adoption from the community of it?
First of all, yeah, it's very difficult to keep on top of everything. So you have many people involved in many fronts, but sometimes when you think, okay, you're an OTel maintainer, so you tell me about the .NET SDK status. He's telling you, no, I work on the exporter for Jaeger. It's in the collector. I have nothing to do with .NET and not even with all the area of SDKs, if you remember the different components or areas that I mentioned. So that's so vast that being able to be on top of all of that is a mission in its own right. Obviously, to maintain the docs and making sure that with the fast-paced progress that I mentioned, such an active project, to make sure that the docs are aligned. And sometimes getting contributions for documentation is more challenging than getting code contributions, as you know from other projects as well. So making sure that it's up to date, helping people because it's moving so fast. So making sure that still remember that the vast majority are just making their very initial steps with a project and making sure that we don't, while we run on the cutting edge, bleeding edge, or to the next signal profiles and eBPF, what do we do with these folks? For example, one of the successes there was when we launched the OTel demo, like a canonical demo out of the box that has, it's called the Astronomy Shop, the mock app, like an e-commerce app that is pretty elaborate, microservices in many different programming languages. And like you have Redis there and you have Postgres database, so really emulating real life microservice architecture that helps people just start playing with with OTel, both instrumentation, seeing microservices in different programming languages instrumented and seeing the collector and and seeing how it all runs together. So this is the one step that was to take care of that. Another piece is like making operable in production. So as it progresses, more organizations start using it in production, and then you need to start thinking about not just, again, the next feature and the next capability. Let's talk about how you operate that. And I mentioned before the OTel operator, but there's beyond that. So, okay, you deploy it with the operator, that's fine. But what happens in the day two scenarios? Like you want to update the configuration, you want to maybe monitor even the collectors, the agents themselves, and see that they're okay. And that got us into what is known as OPAMP. Forgot the short. Do you remember like the specification for monitoring the agents themselves, the agent monitoring protocol? Probably agent monitoring protocol, something like that. So OPAMP is a way to take care of all these day two scenarios. How you get monitoring data from the OTel collector and the agents themselves to monitor them, how you can push configuration and get update on, okay, which version is now deployed, and all of the things that you would expect in production systems when you install clusters of collectors or things like that. So I guess this is another challenge that we face. These are the sorts of things that can come to mind, I guess.
Open Agent Management Protocol, OPA.
Okay.
That didn't come out of my head. I need to be honest about that. But that's what OPAMP stands for.
Yeah. So these are the sorts of things, and these are important because these are on the tooling side, and then there's the discussion on the specification. Because on the one hand, it sounds beautiful. Let's get one unified specification to conquer the world, to rule them all. But it's not trivial to get specification that will meet all the challenges and all the needs, especially when you don't go into a greenfield like logging. Logging is a brownfield, classic brownfield. It's been for the past 80 years or so, and you have lots of legacy and lots of standards and protocols and things like that. How do you create now something that will not be breaking to people that are already using some things and are used to some things? So, and even younger things like profiling. It's been a lot of discussions in the group. That was the topic, as I mentioned, for the last episode. So it's fresh, like top of mind for me now. The discussion, you have the Elastic folks bringing what they used, and the Datadog folks bring what they used, and Grafana Labs, and there are also startups that started, and some of them have been acquired, like Pyroscope and Polar Signals and others, and each one has its own way of thinking and finding a way to balance all these concerns. And do you reinvent the wheel, or do you go with something existing like pprof by Google? And is pprof itself enough, or do you need to do extension and maybe fork it? And lots of these discussions to find a way to create a specification that will not be limiting, because specification sounds nice, but let's remember that what we don't want it to happen, and I have seen that in the past, is that the specification makes it harder later on to innovate. So you need to leave room also for flexibility for innovation as well. So I guess these are the main challenges that I've seen in that regard.
Yeah, as you're talking about it, it's all kind of hitting me, because there's that one central location, and I keep calling it a central location for OpenTelemetry because it's one location that's ingesting data from various resources. But for that one location to actually be the location, I mean, there are tons of various different integrations that are needed, like not even with the monitoring and observability tools, but with the underlying platforms, whether it's a VM, whether it's Kubernetes, whether it's an application, right? Whether you're importing libraries and stuff into application code. So yeah, I mean, it sounds like you could go on for days just telling us about all the different things that you ran into while you were building it.
Talking about specifications, there were some very impressive wins. So first of all, OTel itself started as a merge of two specifications out there, Open Tracing and Open Census. Luckily enough, both of them were under the CNCF, so that helped bridge the divides there and merge that together. But also very lately, again, the last KubeCon, we announced that Elastic Common Schema, ECS, which has been merged into OpenTelemetry specification. So you have another very major and well-established community, in this case in the logging realm, that we're able to bring on board so that we can join forces and have one unified. We don't need to split the open source community between the two specifications, and we can work together. So this is a success story in creating this unification by merging. And as I mentioned, another example is the collaboration between the Open Metrics and Prometheus community and with the OTel community with regards to how to model time series data metrics and so on. So there are successes, but it requires a lot of effort, many, and the credit, maybe it's the time to accredit all the different members in the SIGs, the special interest groups and the working groups, and everyone working very hard and diligently to come up with these specifications and to do that. So it's very, very important. I think that the real power of OpenTelemetry starts with the open specification, the open standard, even before the tooling itself.
And you're on the exciting path. I think it's time to share that announcement that probably everyone would hear about till this episode comes out, but you're on an exciting path to graduation, right?
Yeah, so OpenTelemetry is applied. I mentioned the graduation, so draft, experimental, stable. OpenTelemetry is as active and as mature as it sounded from everything I said, was up till now an experimental project in the CNCF, in the maturity life cycle of the CNCF, and now it applied to become a graduated project. This is the highest level of maturity in the CNCF, and the application has been done to the TOC, to Technical Oversight Committee, and that's very exciting, and actually also an opportunity to call upon all the listeners who are users of OpenTelemetry to chime in, check out. It's an open issue on the CNCF GitHub, and another way that you can chime in and also strengthen the case is if you are users of OpenTelemetry, you can add yourselves to the list as adopters. So there's a GitHub page for the adopters. Name yourselves, name your organization, and this will help show the TOC and to everyone the extent of usage of OpenTelemetry, especially production usage of OpenTelemetry. Invite you all to chime in on that conversation and help us make the case for the graduation.
Awesome. Looking forward to the outcome.
I don't know if it's okay with you or if you have a way to put that on the show notes. Happy to provide the link, and we can share that. And in general, if you want to follow, if you're not already following OpenTelemetry, then OpenTelemetry, there's the GitHub repo, obviously, under the CNCF's GitHub. And there's the CNCF Slack, where you'll find many, many, many channels about the different areas that I mentioned for OpenTelemetry, for the languages and for the specifications and for the signals and so on and so forth. So find the channel that is right for you. And if there is a specific SIG or working group that is of interest to you, usually they have also regular calls that you can join, in addition to the Slack channel discussions that you can chime in there and actually get to know the people and get into the conversation. So these are the main places. There are obviously the website itself, OpenTelemetry.io, that you can find lots of documentation and then just to provide some resources. I also wrote a guide to OpenTelemetry for the beginners. If this is helpful for you, I can provide this link as well. So, and the demo that I mentioned is also a very good place to start hands-on experimenting with the project. So just to reference a few good pointers.
Awesome. Very, very cool. So, Christina, before we start wrapping up for the day, is there any other questions that you had?
I think that you provided quite a great introduction to the OpenTelemetry project, Dotan, and what it is possible for. And I think also for our listeners, it also became clearer that OpenTelemetry can bring its value also for the underlying platform like Kubernetes that applications may be running on. So I think there are some great resources out here to check out. And if our listeners are coming to KubeCon and Cloud Native Con, there is normally an observability day also happening like before the main event itself. And I think a lot of the sessions there are also related to the OpenTelemetry project. So for more information, I think that's a great forum to join and kind of interact with the maintainers, right?
Yeah, so Observability Day has been a very successful day. It's one of 2 or 3 that were co-located events that were really so busy that they mandated a whole day for them. Some of them, most of them were like half a day or something. So a lot of traction around the Observability Day. It's not just OpenTelemetry, it's also Prometheus and FluentBit and others, but a really good place. And for OpenTelemetry specifically, like any other project in this maturity, there is a designated meeting within the main KubeCon event. So you can chime in there, and there's a discussion with the maintainers and discussing roadmap and also soliciting feedback on what's important. That's how the profiles, for example, was chosen to become the next major thing in the signals. So check out these as well. And on the end users this year, this KubeCon, on the end user activity, there will be a designated slot for that. So you can find it all over the place at KubeCon. And again, as I said, because the episode will probably come out after KubeCon Europe, but feel free to reach out through any of these channels that I mentioned for the project. If you want to reach out for me directly, happy to help as well. I'm Horovits, and probably all the channels you'd be looking for, Medium and Twitter and Mastodon and LinkedIn and whatnot. So just feel free to reach out as well if you have any questions and comments. And yeah, hope to see more faces involved.
Awesome. Well, thank you so much for your time today. Really appreciate it. And thank you for everybody listening.